Hello Internet, thank you for watching. This is going to be a quick video, basics video about batteries and voltages. I'm going to start with lead acid and lithium ion. I'll do more videos later about some other chemistries like lithium iron phosphate and nickel-ion, all those. But I'm going to try to really stick to these. This video is really for people that are like, DIY electric pedal bikes or RV off-grid, the Powerwall guys, the boat guys, anyone who's trying to replace lead-acid batteries with lithium. I'll do a video about the reasons for that later. So let's get into this. So real quick, lead-acid batteries, they are 6-cell batteries. So when you buy one battery, it's actually a battery pack. And that is important to know later in bigger systems, but we have to do math whenever we try to interact lithium ion with lead acid systems, and this is part of the reason why. So when you balance charge of lithium ion, you always do it, has a BMS, you top balance, whatever. Lead acid, you don't really hear about that. Well, the reason is if you run them up to 14.5, 15 volts, they'll actually balance themselves out. And that's why we have these broad voltages. Why I made this graph here is to really try to explain why we see these voltages and how we can modify things to work with each other. So let's talk about that. So 12.6 to 12.9, depending on type of battery, is 100% on a lead acid battery. And when you charge them, most chargers will go up to around 14 volts. Some will stop at 13.8. Some will stop at 14.7. So in a 48 volt system, this could be as high as 60 volts. So that's the top side. On the bottom side, our cutoff is 10.5. That's like dead. You don't really want to go there. You really don't want to go below like 11.8 either. I know it's like 40% state of charge, 50% state of charge, but unfortunately it permanently harms the battery. Likewise in lithium ion, that's like 2.8, 3, somewhere in there. Depends on your battery. You got to check the data sheet for the manufacturer. So yeah, I know lead acid guys that's why they don't like, hear these things. But if when you're trying to make your battery last 5 years or 10 years, these numbers become important. For lithium ion, that number is 3.9 actually. They don't like to be charged. I mean, they run fine, but if you want like 1,000 cycles, that's 1,000 cycles. That's a little more than 3 years if you cycle a battery every day. You really don't want it to go past 3.9. You don't want it to go under like 3.2. So these numbers are important to know, and then we have to unfortunately start doing math. So without getting too in depth, let's review real super fast. So float, when a 12 volt battery gets charged up all the way to 14, it'll usually come down to 3.2, 3.6, and the charger will hold it there so that when you need the power off the battery, you've got a full 100%. Lithium ion doesn't need float. You run them up to 4.2, you unplug it from the charger, you check it a month or two later, or even a year, it'll be like 3.9. So they don't need to be float charged, they just be cut off. There is constant current, constant voltage charging. I'll cover that in a later video, more advanced video, but we'll not worry about that right now. We're just trying to make lithium batteries work when you have a lead acid battery. So what brought this up? Why did I make this video? So I bought this, I build things all the time and no big deal, but I bought a power inverter, and that inverter had a charger. So I was like, oh wait, I could use this more for like, my camping and whatever. I could actually use this for something. I could do like a solar power thing. Well, then I started looking into the inverter, and as you can see here, it had a bunch of different voltages. Here's the maximum. That's the important number. And it had some other ones. So I was like, ooh, I could probably do this. So I did the math real quick. Well, mine was 24 volts, so I had to times everything by 2. And where's that screen? Let me mousy. All right, so I times everything by 2, and so 14.5, which is the max the charger is going to output, times by 2 is 29 volts. So 29, that can't be over the 4.2 per cell for lithium. So if I have a 7-cell pack, that's only 4.14 something volts. So I could use a 7-cell pack with this inverter, potentially. I don't really want to charge it up to that all the time or float it there or anything like that. So I want something lower, and luckily you can do lower. So I picked the middle number, 13.8 times, times 2, 27.6, divided by 7, 3.9. I could use this inverter, not only for its original intent and purpose. So sure enough, my crazy ass took one of the hoverboard batteries that, Mr. J who made famous on the Facebooks and the YouTubes, and took one with a, analog power BMS, and cut it down to 7 cells. It's actually 7-cell series, 2-cell in parallel. I'll do a video on that later. And hooked up to the inverter. Did 4 of them, actually, because I used the rest on my electric bike. And it worked. It worked really well. And discharged it, recharged it, and then for fun, I ran it a few times. I left it plugged into the wall, so the inverter would switch between, basically on-grid and off-grid, batteries, and because it had a charger, and it worked. So, of course, that inverter it used what it was supposed to be used for, and now it's going to replace my computer power backup. So that was the reason for this video, and I wanted to try to help people understand that when you're interacting these lithium-ion batteries with lead-acid systems, we have to be aware of these voltages, and that's why you see a lot of off-grid Powerwall, RV stuff is 24 volt or 36 volt. So and sometimes you can't just use like a 36 volt lithium pack will be 10 cell. Sometimes an 11 cell might be better because of those high voltage cutoffs points. And you always also have to be aware of the low voltage cutoff. I am lucky I can just make a low voltage cutoff thing that'll just cut battery connection, or maybe I can open the inverter and to force it to go back on grid or something. Those are easier for me, but those are things that you guys have to look out for that automatically will happen, because you don't want to harm your batteries. But you can do this. You can replace lead acid with lithium. We can now use these readily available, higher energy density, more importantly, less maintenance and more like power usage per cell technologies, and the crazy part is you can get them extremely cheap, like those hoverboard batteries. You can get them used out of laptops and power tools where one cell went bad in the pack, or the pack just wasn't used that much, or it sat on a shelf forever and now they don't sell that laptop anymore. Lithiums can sit on a shelf for a couple of years and that doesn't hurt them, as long as they're not, there's not a circuit running, if they're just, a battery pack not plugged in. Lead acid can't do that. Fun fact, actually good thing to know, is whenever you do buy lead acid cells for whatever your project, always take a multimeter and test it. You want that cell to be over 12 volts. So when you buy it from the store, if it's 11.8, say, hey, guy, I can't take this one. Tell someone at the store, they can charge it back up. But really get the 12-volt cell. It's another basics tip. Yeah, I'll end the video here. I'll make some more later. If you guys have any ideas, comment, let me know. Let me if you have questions, about these things. I've been playing with this stuff for years. I actually kind of feel bad I didn't contribute to the community sooner. But yeah, let me know. Thank you for watching. Have a good day. I'll see you later.